So how do you solve a quadratic? Well, that is something that you should have learned in math too, but there's a good chance that you need to be reminded of it. So let's begin with a fairly straightforward one. Just to be clear, a quadratic is anything that has a squared as the exponent. And you have multiple different ways that you can solve a quadratic. You could factor it, you could do quadratic formula, or you could graph it and look for the x-intercepts. For today, we're going to work on factoring. So as I get my quadratic and I'm wanting to solve it, I'm going to begin by factoring. Factoring, we've covered. What multiplies to be the back number, but adds to be the middle number. You can play around with it, but hopefully you will find that -8 and +1 will make both of these expressions true. Therefore, x minus 8 and x plus 1 are my factors. Now, one thing I want to point out to you is that these are factors, not solutions, and I'm hoping to solve the quadratic. So we need to make sure that we make the distinction between factored and solved. The only difference is that you take the factors and set them equal to 0. So once you have the factors, you set them each equal to 0 and you solve them. On this one, I will add 8, and on this one, I will subtract 1. Now those are solved. So that answers my first example. Again, big difference, factored, solved, and we are looking on solved this week. Let's try one more time. One thing I did forget to point out in example 1 is that you do always have to look for a greatest common factor first. I jumped into the fact that it was a trinomial last time, and that was a mistake. This time, I do have to pay attention to the fact that there is a greatest common factor. I've got an x in both positions. So, as previously taught, we'll take that x out. X squared, take away x, leaves an x, minus 5. And this x is going to go away, so it just leaves 5. Again, keep in mind that these are factors, but they are not solutions yet. So we can't leave it like this, we need to continue. After factoring, to get to the solved step, you set each of the factors equal to 0. Well, the first one's not very exciting. There's not much to solve there. The answer is just 0. The second one, we will add 5 to both sides, and that gets us +5 as our other solution. And we are finished with this problem. So these two examples use factoring as our solution process. So what happens when factoring is not an option? If you look at this, you could attempt to factor what times what equals 5. That will also add to be 3. And you can play around with it all day, but that's not going to happen. So we still need to get a solution. How do we do it if factoring is not an option? You may recall from Math 2 that we learned this thing called the quadratic formula. X equals -b plus or minus square root b squared minus 4ac all over 2a. Now, I'm not going to make you memorize that, but you do have to be able to use that. And this is a prime case of when this would be an option. You do need to know what a, b, and c are to fill this out. The a value is the number in front of the x squared. The b value is the number in front of the x. And c is always found at the end. So as I get ready to fill this in, x equals -b. So I'm going to put the 3 value in for the b, plus or minus square root b squared minus 4. I'm going to fill a 1 in for the a and a 5 in for the c, all over 2 times a. You can see that every time I plugged a number in, I did put a parenthesis around it. I consider that to be a good policy. And now I have to go back and start simplifying. This just becomes -3 plus or minus. 3 squared is 3 multiplied by 3. That would be 9. And 4 times 1 times 5 will become 20. All over 2 multiplied by 1, which is just 2. Next step, The negative 3 will remain, but on the inside of the square root, I can say what 9 take away 20 is, and that's negative 11. The last thing we need to remember is how we deal with negatives inside of a square root. What I will need to do is pull an I out so that 11 is no longer negative, and I am finished with my quadratic formula. Now that was kind of fast, but it should not have been the first time seeing that, and you can always re-watch the video if you need. We're going to do one more example down below. So this is another example of a problem that is not factorable. There are not factors of 2 that will add to be 4. Because it is unfactorable, I'm going to have to use the quadratic formula. A is in front of the x squared, b is in front of the x, and c is at the end. So as I get started, x equals negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. Again, I put parentheses around each of those numbers because I do find that they're important. And now I'm ready to simplify. Negative 4 will just be negative 4 plus or minus 4 multiplied by 4 is 16. 4 multiplied by 1 multiplied by 2 become 8 all over 2. The inside of the square root can be reduced. 16 take away 8 is 8. And you may be tempted to want to stop there. I don't have to worry about taking an I out this time because the 8 is not negative. However, I do have to try to reduce radicals when possible. 8 is a number that can be reduced. If I rewrite 8 as 4 multiplied by 2 instead, there is a perfect square for 4. So the square root of 4 is going to become 2. This square root of 2 doesn't have a square root, so it needs to stay right there, all over 2. And last but not least, we can divide these both by 2 now. Negative 4 divided by 2 is negative 2, and 2 divided by 2 becomes 1. And that is how you do a simplifying quadratic equation.